All right, so let's wrap this up. We were talking derivatives of inverse functions, and here's where we left off, right? So let's look at a few more examples. I think it's going to take a little bit more before you probably feel comfortable with this. So what about this guy here? We have a decreasing function. We know that this is true. G of 4, we're told that G of 4 equals 6 and G prime of 4 equals -2. And they're wanting us to find which of the following statements about the inverse of G must be true. So let's call that F, right? And if we're trying to find if the inverse of G is F and we want to find F prime of X, then this is the relationship we use, right? F prime of X is equal to 1 over G prime of F of X. Okay, so then we need to decide what's the input going to be for our inverse function F, and what's the output going to be? Well, we know that G of 4 equals 6, right? So we're inputting a 4 and outputting a 6. So does that make sense? For G, we're going, that's the row where we're going right to left. We got the input on the right and the output on the left. So we said input was 4, output was 6. Okay, give me 1 to 5 on that. Does that all make sense? Okay, so then for F, which is the inverse, it's going to be the opposite direction, right? We're going to be inputting a 6 and outputting a 4. So let's test number 1 here then. So number 1 says F prime of 6 equals 1 over G prime of F of 6. So what's F of 6? 4. Everybody see that? Right? Because we read it this way. F of 6 equals 4. Okay? So we're doing, for part A, this is the same thing as saying 1 over G prime of 4. Well, what's G prime of 4 is -2. Okay? So is that true then? Is 1 over G prime of 4, which is -2, is that equal to 4? No. Everybody agree? That's a false statement. Okay? So that one we can cross out. What about B? Why doesn't B make any sense for us? Say it again. Well, what would that imply? Let's write out that statement. So this one would imply that F prime of -2 would equal 1 over what? G prime of F of -2, right? What's F of -2? I mean, do we know? We don't know, do we? Because we're not given an ordered pair that involves a -2, right? This is a derivative. This isn't a function. So we don't have, this is not like here with this first example, right? They give us G of 4 equals 6. Well, that means we're inputting a 4 and outputting a 6 for G. This doesn't tell us that, right? This is telling us we're inputting a 4 for G prime, not G, and outputting a -2. So we have no clue what that is, right? We're not given any information that relates to that. So therefore, we can cross that one off too. Okay, give me 1 to 5. Does that make sense? Okay, that's not an ordered pair that we can deal with. How about this guy right here? This is the same, C is the same as A, isn't it? Right, everything, it's asking us for the same thing, G prime, which is, or G minus, which G inverse, I can't talk, which is f prime of 6. Well, that's what we calculated up here. F prime of 6 is equal to 1 over G prime of 4, which is equal to, if we finish this one, I guess, that's equal to 1 over negative 2, which is the same thing as negative 1/2. So of the last two, it's D. Okay, everybody agree? Okay. Okay. Make sense? Okay. Questions? All right, so let's go back to our, this is the one we started with, right? Yeah. Okay, I want to go back to this one, but I just want to show you that we can do this one in a way that's going to be more consistent with our implicit differentiation stuff. It's the same process, right? But what if I were to rewrite this here as y equals x cubed plus 2x minus 1? Okay, that's f, right? So if g of x is the inverse of that, how would I write g of x as an equation involving x's and y's? Say it again. Okay, but how is it going to change that? This is just a, here we've just rewritten the definition of f of x where I've just substituted a y for f of x. Because what we're going to end up doing is just differentiating implicitly with respect to x and getting y primes eventually. Okay, but if g of x represents the inverse, Becca, what do I have to do to that equation? Switch the x's and y's, right? Okay, so then this is going to give us x equals y cubed plus 2y minus 1. Now there's an equation for the inverse of f of x, which is represented by y. We're not going to solve for y. That'd be hard to do. But if we want to find what g prime of 2 is, well, that's the same thing as saying y prime when x equals 2, right? So we could just implicitly differentiate then, right? What are we going to get when we implicitly differentiate on the left side with respect to x? What do I get on the left side? 1. What's the derivative of y cubed with respect to x? Okay, everybody get that? 3y squared, y prime by the chain rule, plus the derivative of 2y, 2y prime, and the derivative of constant's just 0, right? So if I were to solve that for y prime, I'm just going to divide each side by 3y squared plus 2, right? Okay. So I get y prime equals 1 over 3y squared plus 2. Okay, so there's my answer, right? We just have to go back here and interpret that. Okay, so now if we wanted to evaluate y prime when x equals 2, when we're talking about the inverse, this would be the inverse row, correct? Okay, so then where does the 2 go? Everybody agree it goes on the right? Because look at that, because I'm trying to calculate y prime when red x equals 2, red meaning the inverse, right? So that goes there. Agreed? I just need to know what is, g of x is really just y, agreed? The red y. I need to know, to evaluate my derivative, I've got to be able to plug in a y there. There are no x's in my derivative when I solve for y prime. So I need to know what goes here. How am I going to do that? I can, yeah. I could go back to the original equation. Here's my original equation, right? So if I use the original equation, let's chase that down here for a second. If I use the original equation, oh, why did I put an X there? That was probably confusing, huh? What did I mean to put there? 2. I meant to put a 2 there, right? That was probably confusing, right? That's a 2. Sorry. What was I doing? Okay, so I could use the original one. In the original one, though, where we're talking about the function, about f of x, right? Y corresponds to f of x, I would be using the top row. And 2 is the output. 2 is the value of y in the original function, and I'd be solving for x. Everybody agree? So I'd be plugging that 2 in there, and I would get the result 2 equals x cubed plus 2x minus 1. I can do that. And what's the answer going to be? What's the solution there? X equals 1, right? Okay. So we get x equals 1, so I could plug a 1 in there. What's my alternative? That works fine. What else could I do? What do you think?
Can you plug it in? So if you go to the inverse of the original function, so x equals y cubed, can you put 2?
Yeah.
So substitute.
Right? If I use, everybody see that? If I use this function here, well, now that's the red. That's the red direction, correct? So 2 is now the input and y is the output. So I would plug 2 in for that term in that case, right? I get the same equation, don't I? I get 2 equals y cubed plus 2y minus 1. Okay. And whoops, I get x equals, sorry. Oh, no, that's right. There we go, because it's 2 in this case. Yeah. So what's the solution? Y equals 1, right? But now we're working in the red row, and so that makes sense. The input would be 1. I could use either one of them in this case, right? Okay, they say the same thing. In either case, all I'm really doing is I'm just filling in this ordered pair. Well, am I reading it from the left or the right is the only difference. Okay. So I can finish this up then. Down here, the solution, this is a red derivative, right? So I've got to be reading it. Now I'm looking at this row right there. Okay, so then I end up with my solution is y prime is 1 over 3 times y squared plus 2. What's my y in this case? What's it going to be? How do I know? Am I dealing with the function or the inverse here? The inverse, right? I'm dealing with the inverse. And so this is the inverse direction, is right to left. Input on the right, output on the left. So y, the output of the inverse, is 1. Okay, so I would be plugging in a 1 there and I would get the result 1 over 3 plus 2 is 1/5. Right? Okay. Make sense? That's what we did. Here, let me pull up our stuff from yesterday. I just want you to see we did this exact problem with a different look yesterday. What was yesterday, the 5th? Right there. Okay. Does that make sense? Same thing. Same exact thing. We just called it, we just didn't use implicit differentiation. Right? Okay, I'm going to take a picture of that and put it in the notes. This is a day where I would advise you to maybe look back at this stuff. Like take 10 minutes, tonight and just sit down and just look at these notes a little bit and make sure you can think through them and the light bulb goes on. Okay. Question? Duluth, you have a question? Oh, just stretching? Okay. I'm right on top of it, though, if there's a question out there. All right, so let's try this one. So find f prime of 5. Why don't you guys work on this for a second? Just we'll work together, work individually, but take a second and work through this, and then we'll talk about it. What are we going to call G? Oh, okay. So F equals inverse of G. Good. Okay. Maria, would you please remind me to read? Okay, what you thinking? Walk me through this.
Do the chart first. Do the chart first. So
Okay, chart first. Okay, so what do we know here?
we have 5 as an input of F. So
Okay, good. Because look right here. So 5 is an output of G, right? Which makes it an input of F. Okay, good. So let's make a little. So this guy right here. That puts it there, doesn't it? I am. Thanks. Yeah. And then that right there puts it there, doesn't it? See what I'm saying? Okay. Okay. Makes sense? Okay. So then now we're good, right? Because then f prime of 5, if we just, we use our relationship, the derivative of it's the inverse of G, right? So f prime of 5 is 1 over G prime of f of 5, right? Okay. Well, what's f of 5? -3. Yeah. Okay, so this guy's going there. And we get 1 over g prime of -3. Well, they probably give us that up there somewhere, don't they? What's g prime of -3? 6. So that equals 1/6. Done. Okay. Give me thumbs on that. How'd we do? Is that we getting there? Okay. All right. Okay, you're going to see some like this on the assignment. This is actually easier. They give you an ordered pair, which is nice. So it takes some of the work out of this, right? So if we want to find F inverse prime, let's call that G first of all. G prime of 174 equals what? Okay, well, how am I going to set up that derivative? What's G prime of 174 equal to? Because I know a bunch of stuff about F. 1 over F prime of G of 174. Okay, we'll look at that, finish this last one up tomorrow, and then I'll let you guys, would you guys maybe want to have a work day to kind of get work on this and get questions answered? Okay.